All right, here we go. Let's do a brief little introduction on how to solve exponential equations, and we're on it. So I have three examples. I think they're kind of in order of ascending difficulty, but we'll see. So I'm going to start with this example over here on the left. And what we're using in problems like these is we're using a certain property that if we have like a to the x equals a to the y, well then we know that these exponents must be the same thing. We know that x must be equal to y. That's kind of the idea that we're using here, okay? And so what we have is we have 2 raised to some power is equal to 2 raised to some power, so it's safe to say that these powers must be equal to each other. And so we just set those exponents equal to each other and solve. If I divide by 2 on each side, we get that x equals 2, and that's our solution to this equation. Okay? Now let's jump to a slightly harder example. Now we're looking at this. And instead of having a base of 2 in both problems, we have a base of 2, but now we have a base of 8. So in this current form, I cannot assume that that exponent is equal to that exponent because they have different bases. But what we can do, the tool we have in our tool chest, is that I can rewrite 8 with a base of 2. And let me show you what I mean by that. If I have 2 to the x plus 4, I can rewrite this 8 as 2 to the 3rd power. Because 2 times 2 times 2 is 8. Now what I have is I have this situation where I've rewritten these with the same base, so I can assume that these exponents are equal. In other words, x plus 4 is equal to 3 times x minus 6. I should probably throw parentheses right there. And so now we can just solve this little equation. So I'm going to distribute 3x minus 18 equals x plus 4. I'm going to subtract x from each side. I'm going to add 18 to each side. And I'm going to divide by 2 on each side. So we have that x is 11 is the solution to this equation. The big thing here is that sometimes you have to rewrite one of your bases with a power so that you have the same base on both sides of your equal sign. Let's look at a last example. Now, problems like this come with experience. Like if you're looking at this, you're like, man, 1/3, how do I rewrite this with a 1/3? Or maybe you're looking at this saying, how do I rewrite this with 81? Sometimes you have to rewrite both sides. Maybe think, what are some factors that both of these have in common? What are some powers that both of these have in common? And with practice, and I'll have another video on practice, you'll see that maybe we could rewrite both of these with a base of 3. And here's what I mean by that. 3 to the negative 1, is equal to 1/3. If you have a negative exponent, it means you kind of flip it and put it down to the denominator. So what I could do here is I could rewrite that 1/3 as 3 to the negative 1 and then bring down my x. And I can do the same thing over here because we have 81 is a power of 3. We have 3 times 3 is, or 3 times 3 is 9, 3 to the 3rd is 27, and 3 to the 4th is 81. And now that we're here, we can play the same game that we played in the other problems. We have negative 1 times x equals 4, and I'm just going to divide by negative 1 on each side and get that x equals negative 4, which is the solution here. So remember, the moral of your story is that if you have the same base, you can assume that the powers are equal. If you don't have the same base, you need to rewrite one of those bases so that they are the same. Sometimes you have to rewrite both of the bases.